Okay, so welcome back to the stream. So basically today we are going to cover like the coding part for the various data structures. We have sort of practiced or sort of understood the intuition yesterday. So I'll just present my screen now. Yeah, cool. So basically, okay. So basically today we are going to discuss something like this. So basically today we are going to discuss the coding part for arrays, stacks, queues. String is pretty much self-explanatory, and then hash map. Okay, so you're going to discuss for all of these. Okay, great. Let me just try to get this thing bigger. Yeah, great. So I hope the thing is quite visible. I've created one file called datastructures.py. You can ignore the other three files here. Okay, so let's see what we can do. So basically yesterday we discussed a few of the things. Okay, we discussed few of the things, and maybe I can just recap them if I'm not wrong here. So what I'll do is I'll just sort of go back up here. And yeah, I think we are sort of familiar with what we learned yesterday. Okay, so basically yesterday we learned about few of the data structures which are at elementary level. So that's arrays. Okay, then we learned about stacks. Then we learned about what queue is, right? Queues, whatever you may call it, and then string. Okay, and then a little about what hash map is. Okay, I think I should just begin with the hash maps functionality. I just described the overview of it, right? So let's see what we can do. So basically, the last thing which I mentioned about hash map, was that hash maps can be used to store something like key and value pairs. Okay, key and value pairs. Hash map can be used to use for that, right? And the example we took was as simple as something like this, right? As simple as something like this, that there are students, right? Students in the class, and suppose one student name is Arav, right? And he scored 35 marks. One more student is Arav and he scored 35 marks. How do you differentiate? How do you differentiate between the two? Well, you do on the basis of their what? Roll number. So roll number, for example, for this Arav is 171 and for this Arav is 185. Okay. So you can say that the roll number up here is key. So you can sort of represent it like this. So 171 is holding the value Arav and his marks, which is 35, and 185 is holding the value, which is nothing but Arav, the name, and the marks again 35. Okay, and this is nothing but what? This is my hash map. So basically up here 171 and 185 are nothing but what? Keys. Okay, this is keys. And what is Arav 35? Well, these can be unique or same, doesn't matter. These are nothing but values. So I know for a fact that it's represented like this: keys, colon, values, something like that, right? Something in this format, where key is always my unique value and values can be same or not same. Okay, that's it. Okay, that's what hash map is. Well, what are the other functionalities of hash map? What are the other functionalities? Like stack has push, pop, and then so on, right? So what's for hash map? Well, there is no such special functionality. You can sort of come up with your own. But some of the most important ones are that, for example, if you are given a key, you are given a key, then you have to get the value, Well, in Python, what I'm going to do is simply write the name of the hash map, which is suppose dictionary. So dict, and whatever my key is. So this is going to return me what? Returns value, returns value. Great. What if I want to add one key? What if I want to add one key? Well, I can just simply write dict my new key, my new underscore key is going to be my new value, whatever the value is. This is how you can add in Python. Okay. Let's see. What if I want to check that if a key is already in dictionary or not? Then I can just simply do key in dict. And this is going to return what? Boolean value. Okay. This is going to return what? Boolean value. So maybe I can just write it again, Boolean value. So Boolean value can be what? Boolean value can be true or false. Boolean value can be true or false. Let me just open up the chat section. Hold on. Yeah, give me 1 second. I'm opening up the chat. I just want to see that if it's there any doubt or not. Okay, let's see. So the first one was for that you are given a key and then you have to get yeah, my bad. I think I got disconnected. So basically, for the ones who have missed out, maybe I can just put it in the chat itself, which topics I'm covering today. Yeah, so basically I've mentioned the things which we are going to cover today. So is it live or premiere? It's a live thing, right? Navneet, hi. Will you discuss what topic you cover? Okay. So basically I've mentioned here that the topics covered are being arrays, stacks, queues, strings, and hash map. Basically, I have covered the sort of like the intuition behind arrays, stacks, queues, strings, and hash map yesterday. And today I'm going to discuss a little about what hash map is, right? Because I covered the overview of it. And then I can sort of proceed with this thing, right? I can proceed with the coding part. Today, the main focus for the lesson is that I'll be discussing about the coding part. Okay, so today I'm going to discussing the coding part for all of the data structures I've mentioned in the live chat itself, right? So which is arrays, right? Which is arrays, stacks, queues, and then maybe like hash map, and then strings. Okay, and definitely I'll be covering the entire thing in Python 3. This is something which I've been mentioning since day one. Okay, so that's it. Okay, and let's see what we can do. So basically what I'll do is that since I've explained a little about what hash map is, right? Let's maybe hop over to the coding section, okay? And then we can figure out where we are missing out on, okay? So the first one we are going to discuss today is going to be as simple as arrays, and how to actually write it in Python, okay? Let's see. So I've created one file here, datastructures.py. I'm using Visual Studio Code here. And then I've just written something like coding part for arrays, stacks, queues, strings, hash map, and then so on. So let's begin with the arrays part. So as I have mentioned that arrays are nothing but a collection, okay? Arrays is nothing but a collection of basically the data types which are similar, right? What I'm trying to say is array is nothing but a collection of data types, and instead of data types which are similar, you can just simply write it as similar data types, okay? Collection of similar data types, which means that the elements are homogeneous, right? The elements are homogeneous and not heterogeneous. That sort of makes sense, okay? So in Python, you can simply represent the array. As simple as, definitely there is another representation which I'll go through. Maybe it's not even required here. So the another representation could be using the NumPy module, right? So NumPy can be used to use array, right? But generally when you are writing a program, right, writing a piece of code, what you can do is simply just write array is equal to whatever the thing is. So for example, I'm going to store the marks of 5 students, right? To store the marks of the 5 students, what I can do is simply create an array something like this, and the marks are going to be like this. So the 5 students marks are what? Those are the marks are like this: 100, 56, 78, 57, and then 45, right? And then I'm just going to simply copy over the marks up here. Perfect. And then I'm going to paste it up here. So that's going to be this. Okay, my bad. So this is going to be 100, 56, 78, 57, 45. Guess what? Copy pasting does not work same on MacBook. So array 100, 56, 78, 57, 45. So this is how you simply declare an array. As simple as that. Okay. This is how you simply declare an array. And there's no such big complication in Python. Okay. So if you talk about a programming language like C, right? In maybe like C, in C, how do you declare the array? You sort of declare the array like this, right? So int array, something like maybe 5 will be there, and then the marks will be there, right? So 100 ... whatever the marks are till 45, right? This is how you declare it in maybe C, right? This is for C, but in Python, it's as simple as that. It's as simple as this, right? Why am I not declaring the array as a tuple, right? Why am I not declaring the array as a tuple? Okay. The reason is that if I perform sorting, then this won't really change the array, right? Because tuples are nothing but immutable, right? So you cannot sort of change them. Okay, that's it. Okay, I think so. The array part is clear. What if I want some of the things, like what if I want the marks of 4th student, the marks of the 4th student? I can just simply write print marks of the 4th student is, and then I'm just going to simply write what? Array of what? 4 will give me the right answer, or array of 5? No, both are wrong. So array of 3 is going to give me the right answer, because the array indexing begins from 0. Indexing begins from 0. So if I want the marks of the 4th student, I do something like this. Marks of the 4th student is array 3, right? Marks of the 4th student is array of 3, right? So I'll just sort of save this. Let's see how it's working. So what I'll do is just simply write Python 3 datastructures.py, and it's going to happily print the marks of the 4th student, which is 57. Up here you can see 57 is being printed very happily, right? So 1, 2, 3, 4. 4th student marks is 57, right? It's easier as that, right? Now what if I say that, okay, please make the marks of the student, fifth student, right? So make the fifth students marks correct, right? And maybe like increase it by 10. Okay, so I'm saying that, okay, fifth student's marks is not correct, so make it correct, right? And increase it by 10. Maybe like I forgot to mark something, right? So this should be what, 55. How do I do that? There are two ways. What you can do is simply reassign the value here. Simply reassign the value. So the first way could be as simple as simply reassigning the value. Okay, simply reassigning the value. So what will it look like? It will look like this. So array of, I'm saying fifth student, right? So it should be 4. Array of 4 is going to be what? 55, right? 55. So 45 plus 10 is 55. But up here I can see that I had only 5 numbers, or the 5 elements, or the 5 students marks. What if there are 10 to the power of 1 crore students? Then if you say that please increase the marks of 10th student, or maybe increase the marks of 1,30,000 student, right? So the student which is numbered at 1,30,000. So how do I know that? I don't know, right? I have to search it and search it up in the entire array, right? Up here I can see simply that, okay, fifth student mark is 45. So the best practice is to write it like this. So array of 4 plus is equal to 10. And believe me, this is going to modify the array, right? So what I'll do is save this. Now, if I just execute this, at first the marks of the fourth student is 57. Up here you can see the new array 100, 56, 78, 57, 45 has been changed to 55, right? And these are some basic operations, I believe so most of you are familiar with, right? And I think this is like basic representation of an array, and that's it for the array part, right? That's it for the array part. There is something also called as multidimensional arrays, right? So something called as multidimensional arrays. Well, how do I use that? Well, how do I and where do I use that, right? I'll get back to it after I complete stacks, queues, and something like that. Okay. So basically, my array part is over. Let's maybe like start with what stack is, right? What stack is. Okay. We are doing a basic understanding of here, right? Because the main part or the main implementation will be in the algorithmic part, right? When you use algorithms, you have to implement these data structures, right? And if there is something which is not explained up till now, right, then I'll be able to explain it at that point of a time itself. Okay, that's not an issue you have to worry about. Okay, so stacks. Let's see what we can do with the stacks. Let's see. So stacks, again, what are the operations stack supports? What are the operations stack supports? Some of the operations that stacks support are as follows. Okay, so it's push, pop, peek, and there can be many other, right? We can sort of make it up on your own. So these are the major 3 operations: push, pop, and peek. Okay, so let's see what we can do. Again, stack can be as simple as an array, right? You can simply represent it as an array, but there is something you have to worry about. I am going to say that in a minute. Okay, so for example, I had taken an example yesterday in the session. I took one example of books. Okay, what I'll do is maybe I'll just sort of get rid of this entire thing. Yeah, I'll just get rid of the space here. Yeah, great. So I mentioned about stack that if this is the bookshelf, right? This is the bookshelf. Okay. So if this is the bookshelf, I want to stack at max, I can stack 6 books. Okay. At max, I can stack 6 books. So what I do is I place the first book, then the second one. This is the third one. So this is 1, 2, 3. This is the fourth one. This is the fifth one. And this is the sixth one. Okay, this is the sixth one. Now some person comes in and says that, okay, I'll also add the 7th book here. So I'm representing it using black. So 7th comes up here. So what will happen is up here, stack overflow occurred. SO, stack overflow occurred. What if there is no book? What if there is no book in the bookshelf and I try to remove one book? Then stack underflow will occur. And again, this is something which I've discussed in the previous session, which was held yesterday, right? So stack overflow and stack underflow concepts we are clear with. So we can sort of see the representation here, right? So book 1 is at the bottom, book 2, book 3, book 4, book 5, book 6, and then till book n, whatever the case may be. Okay, till book n. So in the array representation, if I'm describing, should I have book number maybe like 6 in the beginning, or should I have the book number 1 at the beginning? Well, if you have already figured out, then you might be correct that book 1 should be at the beginning in the stack. Okay. So similarly, what I can do is simply have book 2, right? I can have book 2, and what I'll do is I'll have book 3, and then I can have suppose book 4. Okay, book 4, and just last one, so book 5. Great. So I have 5 books in the stack. Okay, my restriction is that I cannot have more than 5 books on top, 5 books on the stack, right? On the stack. Okay, I cannot have more than 5 books. Right now, how many books do I have? Book 1, book 2, book 3, book 4, book 5. Do you know how this looks like when I'm trying to visualize this? This looks like this. Okay, this looks like this. Wait, I'll just sort of write it up here itself. So this looks like this. So this is nothing but a multi-line comment. You sort of have 3 quotes up here, and then you can have 3 quotes up here as well. Okay, so let's see what we can do with this. Okay, so the representation is going to look like this. Book 1, on top of that, book 2, on top of that, book 3, and then on top of that, book 4, and on top of that, book 5. Right? This is how this representation is going to look like. Okay, and this is the bookshelf. This is the bookshelf. This is nothing but the bookshelf. Okay, this is the bookshelf. What I have, this is nothing but the bookshelf, right? The last one. So basically, some books are on top: book 1, book 2, book 3, book 4, book 5. And my restriction is given, right? My restriction is given up here. It's clear. It's clear. My restriction is that I cannot have more than 5 books. I cannot have more than 5 books on the stack. Right now, how many books do I have? 5. Okay, great. Now I'm fine. I'm good to go. What if I add 1 book to the top? I add 1 book to the top here, right? I am sneaky guy, so I add 1 book to the top here. So I'll just add 1 book here, maybe like book 6, right? So what will happen is, suppose I add 1 book here, so maybe like I can just perform operation stack dot append. So basically, append can be used to sort of add something to the end of the array here. So basically, this is an array representation, right? So an end of the array up here would look like this on top of the stack. Okay, it's as simple as that. So stack dot append, maybe like book 6, right? Book 6, great. So now my stack is going to look like this. Now my stack is going to look like this. Instead of till book 5, my stack is having till what? Book 6. Okay. Now there will be an error. So how do I check that? How do I check that? So I check it like this, right? So what I'll do is there are 3 ways. Okay. There are maybe like 2 ways. The first way is comparing with the length of the stack. Comparing with the length of the stack. Comparing with the length of the stack. Right? Length of the stack. And I think I made a little spelling mistake here. So comparing with the length of the stack. And the other way can be to do some string parsing and get the book number. Okay, do some string parsing and get the book number. Okay, do some string parsing and get the book number. What do I mean by string parsing? Well, in simple terms, I mean that, okay, just read the string here and get the last value, which is the number here, right? Get the last value, which is the number here, which is 5, right? So that can be also done, but I'll explain what's the disadvantage of this method, right? What is the disadvantage of this way or an approach? Let's see with the first one. So comparing with the length of the stack. So I can do is, if the length of the stack, if len stack, right? What was my restriction? So restriction is I cannot have more than 5 books on the stack. So if len stack is greater than 5, then I can simply print what? I can simply print stack overflow, because that's not what I want, right? Else what I'll do is I'll just have something like print it's okay, right? It's okay. That's not a problem, right? That's not a problem. It can be accommodated. Okay, great. This is the first approach. Let's try to see if it works. So what I'll do is simply execute this file again. So up here, you can see we got stack overflow, right? Happily, we got stack overflow because we appended a book 6 here. what if I comment this line out? What if I comment this line out? Then that means that I won't get this Stack Overflow right now, right? So let's see. Right now, my stack is going to look like this. Book 1 till book 5. Book 6 has not been added yet. So I've commented this line. So what will happen? Let's see. I'll just do this. So it's saying it's okay. Definitely it's okay because I made a little condition here and there. So if the length of the stack is greater than 5, then Stack Overflow, else it's okay. Okay, let's see. Now, what is the disadvantage of this? It works 100% of the time. This is its advantage. Comparing with the length of the stack, it works 100% of the time. But what if I do some string parsing? So in string parsing, what I can do is I can just write last book number. Okay, last book number is going to be stack of -1, right? -1. Why am I writing -1? In Python, sort of -1 means the last index, and Python supports negative indexing. That's something you have to be care about, right? So will you share any PDF notes for today? Let's see. Let me just see again. Yeah. So will you share notes for today? Okay, maybe I can update this in the dashboard where the course has been like the course progress is being mentioned or shown or visible to you. Maybe I upload the for that. I think there will be no such big PDFs, but I'll this coding files, right? .py files. This I'll be uploading. Data structures.py. I'm uploading that. Okay? If that makes sense, right? So let's see. Yeah, let's get back to it. So -1 is going to what? Point to the last part, right? So up here, I'm doing a little this thing, but wait, I'll just show that what I'm trying to do. Yeah, what I'm trying to do is suppose excuse me. So suppose the string is like this. Book maybe like 5, right? Book 5. So this is the string as of now. S is this thing. So how do I get this number in the format of a number, not even a string? This is a string, right? This is a string or a character as of now, right? But I want this in the form of a integer, right? Not float, right? Not float. So I want this in the form of an integer. I do a little split functionality here. What I do is I can just simply write s dot split, right? S dot split on the basis of what? Space. This is nothing but space. Remember, this is not, I'm not writing it like this. There is a space in between, right? So you have to be careful of that, right? So up here, a little space is there and only one space is there, right? One space bar on your keyboard will do. So one space is there. So this s dot split is going to split book 5 into like this. So it's going to split it like this. So book and then 5 will be up here. So I know when this is getting splitted, this sort of converts into an array internally. Okay. This sort of converts into an array internally when I'm splitting it on the basis of space. So this is the space here, right? And how do I access the last part here? Again, I can just use a negative indexing. So -1. So s dot split on the basis of space, -1 I'm taking. So I have 5 now. So as of now, this is nothing but 5, right? And if I want to convert this to an integer, I just do a simple typecasting. So int, if I just add up here like this is going to give me what? 5, only 5. Okay, let's see. Let's try to implement this. So what I'll do is, instead of writing stack of -1, what I'll do is I'll just write int of stack of -1, right? So that's pointing to the last book number, right? Or the last book value or the book description, stack of -1 dot split on the basis of what? I'm not going to leave it like this. I'm going to have a space. And then again, I'll have something like -1. Okay, I'll have something like -1. And this is going to, let's see, it's going to give me what? It's going to give me the last book number. So I'll just have last book number is nothing but last book number. Okay, my bad. This should be last book number. So let's see. I'll just try to save this. Let's see. So it's saying that the last book number is 5, right? We got it, right? We got it. And again, we have got this in which way? We have got this in a integer way, right? Not a string way. So type this thing. I'll again save this. If I want to check the type of it, then see, you will say that last book number is of class int type. So basically I got it of what? Integer type. Okay. So as of now, this is giving me what? Last book number is 5. Okay. You might be saying that you did some thing here and there. So what if I just remove this thing, right? If I just remove this comment which I wrote, so this is going to throw me what? This is going to throw me Stack Overflow, and the last book number is 6, right? Last book number is 6. Let's see. What I'll do is type in like this. So you can see Stack Overflow is there because I removed the comment line, which means my stack length is more than 5. If it's more than 5, it's going to give what? Stack Overflow. Once I have Stack Overflow, I don't care about it anymore right now. So last book number I'm getting, last book number is what? 6. That's what I'm getting here. Now, there is a way to check with the last book number as well. What I can do is just simply write, if last book number is greater than 5, I know again Stack Overflow will be there. I know that Stack Overflow will be there. So I'll just write Stack Overflow in small caps. So that makes sense. Right, great. So let's see what it's giving, right? So it's giving me what? Stack Overflow, last book number is 6. And again, on the basis of the last book number, I got Stack Overflow. But is this a good practice? Let's see if this works or not. What if the last book number, or suppose let's change the orientation of this. Suppose the first book number is 100, second one is 2. This one is suppose 33 or 322, book number 41. This is maybe like 55. And the last book number is suppose 1. Suppose the book number 1 has been added to the very top or the very end. Then what will happen? What will happen is, if I just save this, right? If I save this, the first one is going to throw me the correct output, which is Stack Overflow. Why am I saying? Because I'm always comparing the length of the stack here, which is always correct, right? And up here, I can just have the last book number, which is what? 1. But 1 is not greater than 5. So it's not going to throw me Stack Overflow. So you can see after this, last book number is 1. Last book number is 1. Nothing is printed. So the best way is to use the length of the stack to check for Stack Overflow conditions. Okay. So I'll just sort of comment this because this is the not so appreciable way, right? What if I say that my stack is like this? What if I say my stack is like this, empty, right? My stack is what? Empty. My stack is empty. And no, let's not have it as empty. That looks bad, right? So what I'll do is I'll just have something like book 100, book number 100. Okay. So right now my stack is having only one book. Only one book is there. Only one book is there. Okay. So what if I say peak operation, right? I want to do the peak operation. What will peak operation do? Is just simply print stack of -1. It just simply prints the stack of -1. Or I can just more formally write it as the topmost book is stack of -1. That's it. That's it, right? That's it. So let's see what it gives. So it's going to give me the topmost book is book 100, because that's what my stack's topmost book is. If I had something like this, right? So if I had something like book 12 and then book 100, if I save it again, book 100 will be the priority or the answer because it's on the top of the stack, right? And that's again something which I mentioned. So the topmost book is book 100, and that's what the functionality of peak is. It's not removing book 100, right? But it's showing me the value itself, right? But what's the functionality of pop? What's the functionality of pop? Let's see. Pop is going to give me the topmost book. Okay, the topmost book is, right? Topmost book is stack of -1. Stack of -1. Okay, stack of -1 is the topmost book, right? But after that, you have to also do something like this, stack.pop. Why? So .pop is, what is .pop going to do? It's a built-in Python functionality that sort of removes the lastmost element in the array, right? So .pop is going to remove book 100, right? So let's see after peak. Okay, so what I'll do is print after peak operation, my stack is what? My stack is stack, right? And up here I can do is print after pop operation, my stack is what? Stack, right? My stack is stack. As simple as that. Let's see what we can do with this. clear. And then if I just try to write it again, maybe I can just use some of these things here. What I'll do is, yeah, I'll just have a blank here, and then I'll have a blank up here as well, right? So let's see. So up here you can see is the topmost book is book 100, because that's what I was doing with the peak operation, right? I'm just getting the topmost book, which is book 100. But after peak operation, my stack is the whatever it was, right? I just got the book info, right? But the topmost book is book 100, which is after the pop operation. But it's saying that after my pop operation, my stack is book 12, because it also removed it, right? One of those most trickier ways what you can do is just simply remove stack.pop here and just write stack.pop here itself, right? Let's see if it works. It might not. Let's see. Okay, it's working, right? So the topmost book is book 100 and it removed it. So after pop, my stack is book 12. So these are a few of these operations, right? Pop, peak, and then already we knew no push, right? So this was nothing but push operation. Let me just show you. So this was nothing but push operation. This was nothing but what? Push operation. Stack.append. You're sort of pushing something on top of the stack. Okay, you are pushing on top of the stack. Okay, you're pushing on top of the stack. Well, writing this type of code is not recommendable. You have to create a function, maybe like a class. You have to maybe like create a class stack and then implement the functions. Okay, that's going to be a better way. I'm just trying to explain the functionalities here through code. Okay, so I believe so. We are clear with what stacks is, right? We are clear with array stacks. Let's talk a little about queue, right? Let's talk a little about queues. Well, in Python, you have something like DQ, right? Something like DQ, right? And then using that thing, you can implement the operations of the queue. But I'm not going to use that. Okay, I'm not going to use that. I'm just going to use an array representation. Okay, so queue is going to be an array as of now. Okay, so there are going to be persons, right? There are going to be persons. Let's see what we have learned from the yesterday's class. Let's try to recall. So as I mentioned, suppose there is an ATM, right? There's an ATM. Okay, there's an what? ATM, and this is the hallway where people come in from the back and go out from here, right? So you come in and from here you go out. Okay, so when the person one comes in, he'll just go walk and then come up here. So I'll just maybe write P1. When person 2 comes in, P2, P3, P4, and then so on till P10, maybe like something like that. So maybe till P5 persons are there, right? P5 persons are there. So what I'll do is maybe I can just create a queue, something like this. So I'll just have person 1, P1, P2, then I can have P3, that's the person 3, then that's person 4, and that's person 5, right? And for all of these persons, where are they going? Where are they actually going? Let's see. So they are going to the ATM. So this is my ATM here. And this is the arrangement here. So person 1, person 2, person 3, person 4, person 5. Okay. And they are going to be entering from the back and going to be removed from the first. Okay. That's it. So for the queue operations, what you can do is the first one can be as simple as NQ. NQ means, what do I mean by NQ? Just forget about what ECQ, EQ is, right? Just focus on what EN is, right? NQ, EN. What can be EN? It can be as simple as what? Enter, right? So you're sort of entering the line or the queue. So you have to enter from where? You have to enter from the back side. So you can sort of write something like q.append, right? q.append, and then you can have something like P6, because that's the person 6 which is going to come in. So what I can do is I can just have print. So after person 6 comes in, my queue is something like Q, right? Now let's see. Let me just execute this. So let's see. It's going to say that after person 6, so it's going to say after person 6 comes in, my queue is P1, P2, P3, P4, P5, P6. Okay. Now what if I say that, okay, person 1 goes out and then person 2 also goes out, right? So you are given a number. You are given how many people have left the queue. You are given how many people have left the queue, right? So maybe I can just have something like M is int import. I can have something like enter how many people left the queue, right? Left the queue, which means that they have withdrawn the money. They have withdrawn the money. So what I can do is I just type or have completed withdrawing the money from ATM. Okay, that's a little overkill here and there, but it's okay, right? So enter how many people left the queue or have completed withdrawing the money. So that's going to be M, right? And how do I update the queue based on that, right? So if I say that, okay, 2 people have left the queue, so I have to remove what? P4 or P5, right? No, that's wrong. I have to remove the first 2 because they are the ones who are going to leave first. It's not like I have to remove P3 and P2. I have to remove P1 and P2, the first 2 or the first M. That's what I'm saying here. So what I can do is simply use the for loop here. So for I in range, right? For I in range, or maybe I can have something like this. I can have something like this. I can maybe like point here, maybe like use the pointer mechanism here. Let's see if we can do that. Okay. So print my new queue after M people, after M people left is what? Is going to be queue of what? M minus 1 till the very end. This is nothing but slicing. This is nothing but slicing here. Okay, this is nothing but slicing here. Let's see. So when I'm saying M is 2, so it's going to take what? It's going to take queue of M minus 1, which is 1. So it's going to go 0, 1. So from 1, it's going to display all the persons till the very end. So this should be, I believe so, M itself, right? This should be, I believe so, M itself. Let's see. So from M, it's going to, so 0, 1, and 2. So basically these 2 are the persons who left, right? And then P3, P4, P5 should be displayed, right? Let's see. What I'll do is I'll just sort of write up here. So it's saying me right now, enter how many people left queue or have completed withdrawing the money from ATM. So maybe I can just enter 2, right? So it's saying that my new queue after 2 people left is P3, P4, P5, P6, right? And because P6, because hey, I added P6 up here, right? So P1 and P2 is not there in the list, right? P1 and P2 is not there in the list. But notice one thing, that my queue has not yet changed. My queue has not yet changed. You have actually not removed it, right? You have actually not removed it. You have just sort of given me the information, right? But see, if I just print the queue again, back to originality, back to where we were, right? P1, P2, P3, P4, P5, P6, right? So what you can do is other approaches can be a little expensive. So what I can do is simply write for I in range, right? For I in range up till what? Up till I'll be taking till M, right? For I in range M, what I'm going to do is I'll just write q.pop 0, right? Why am I not writing I here? It's a little tricky thing, right? If I just write I, let's see if it works or not. Let's see. So what I'll do is I'll just maybe like have something like this, print q, right? Print q. I'm going to print q after maybe like the next line. Cool. So what I'll do is I'll have the same thing again. So suppose 2 people left. Okay, 2 people left. Up here I can see P2, P4, P5, P6, right? After I removed the queue, after I removed 2 persons from the queue, which are the top 2 most queues, the top 2 persons, right? So P1 and P2 should be removed, and P3, P4, P5, and P6 should be there. But what am I seeing this? This is quite rubbish, right? P2, P4, P5, P6. Where is P3? And where is P1? P1 is removed. Good. Why is P3 not removed? That's where you have to have a little bit of general logic here and there, right? So what's happening with the pop function? When you are not providing, listen me carefully, when you are not providing anything, it's going to remove from where? It's going to remove from the bottom. Let me just try to write this. So if this is an array, 1, 2, 3, if you write dot pop, and you don't provide anything, then 3 is going to remove, right? And if you do pop, and you provide any value here. Okay, any value. Suppose I provide 0, then it means that it's going to remove from the 0th index, right? And if this is removed, then my 2 is at the 0th index. You have to be careful with that. One big mistake I did when I was learning Python, was with this only. I was not able to understand how indexing works. So see, if I'm writing my array as this, right? If my array is like this, 1, 2, 3, 4, 5, and then 6, right? What am I doing there is for I in range M, right? And M is what? 2. Okay. So I is going to have what values? 0 and 1. So for 0, array of 0, 1 is going to be removed, right? Okay. I'm glad 1 is being removed. Now my indexing is like this. Now my new indexing is like this: 0, 1, 2, 3, 4. Now 1 is to be removed. So 3 gets removed. That's why you are seeing 2, 4, 5, 6. That's why you are seeing what? P2, P4, P5, P6, right? P2, P4, P5, P6. That's why you always have to have 0 if you want to have to be removed from the beginning, right? I hope that's making sense. So pop of 0, Control S. I'll just clear everything up here. And then maybe I can just have, maybe like I want to remove 2 persons, right? So I'll have P3, P4, P5, P6. What if I want to have removed like 4 persons? Let's see. Just going to have P5, P6. Also, my new queue after 4 people left is P5, P6. And my new queue has also been updated here. Up here, my new queue was not updated. I was just using slicing. I was cheating here, right? That's something which you should not be doing. So basically, after 4 people left, I'm doing a slicing here, and therefore I'm able to get it, right? But up here, I'm actually removing. Okay. So I hope the queue operations are sort of clear, right? Queue operations are sort of clear. What again you can do is let's understand a little about strings. So strings are basically self-explanatory. So for example, if you had a name, right? If you had a name, and suppose you had an email. Okay, suppose you had an what? Email. Personally, my email address is this. Okay, suppose my email address is this thing, applicable.target, or maybe I can just have something like this. So my first last name, right? First last name @gmail.com. Okay, suppose in an organization you have something like this. First last name, or I can just simply write first underscore last name, right? @gmail.com. Or let's just get more serious here. So I can just have something like Rahul@gmail.com. Okay, Rahul@gmail.com. And in the organization, suppose in the company, every person has the same format. What is the format here? What is the format I'm talking about? The format here is the name of the employee should be there, @gmail.com is there. Okay, this is not actually the format company follows. That's a really bad format, but that's it, right? So name @gmail.com should be there. So suppose Rahul is there, Rahul@gmail.com. Suppose Vaibhav@gmail.com, Arav@gmail.com, something like that, right? Something like that. So that's it, right? So this is the format company is following. And someday the company manager, the manager, or a data analyst comes in and says that please give me the names of all the employees of the company, all the employees. Give me the names. So give me names, right? So what you can do here? Let's see what you can do here. So up here I can see, suppose email is nothing but like a string, right? Is a string, right? So I can just have a string of an array here, right? I can have a string of an array here. That's not an issue. Okay. So Rahul@gmail.com. Suppose Arav@gmail.com. And then I can have something like Riya@gmail.com. Okay. Some random names I'm taking: Rahul, Arav, Riya. Great. Now see one thing. You are a quite smart person, right? What you can do is you can just simply have the names and just look at them, right? You can just look at them and try to have some relationship here, right? So you can see that this length, name length is 1, 2, 3, 4, 5 length. Okay. Again up here, 1, 2, 3, 4, 5, right? So what you are doing is, you are smart enough. What you do is do slicing here. You do slicing. So if you had to print the names, what you can do is print. Okay, you can just loop through them. So for values in email, right? You are a smart person. So name is nothing but what? Values of till 5, right? Values till 5. Let's see. So 0, 1, 2, 3, 4, 5. Great. So this is going to give me what? Rahul, Arav, and Ria. Let's see if I'm right or wrong. Okay. You are a good person. You have a good observation skill, and therefore you are able to figure out something, right? So the first five characters are the names usually, right? Up here also, and maybe up here. I'm not seeing that it's 5. Let's see. So what I'm going to do is just clear this entire thing, and I'll have Python 3 data structures. Okay, that's something with that thing. Okay, let's see. So name is Rahul, name is Arav. Up here, I can see there's a big error. And data analyst, your data team leader will be what? Very angry, right? Name is Ria at. What is at here? What is that? Is that a name? No. So how do you deal with this, right? What if this was AA? But again, this is going to run fine. This is going to run fine, right? Suppose this is 1, 2, yeah. This is going to run fine. But what if someone has a name big as Rahul Subramaniam, right? A South Indian name, Rahul Subramaniam. So if you do something like that, only Rahul might come and Subramaniam won't come. So that's a big mistake, right? So the best way up here, just to manipulate strings, is something like this. So you can have something like this. So name is going to be, you have to use again the split condition here. You have to use the split condition. Again, you can here use split with the dot part or the at part. I see that the at part is going to split in which way? Let's see. So if I'm using the at part, okay, okay, let's see what I can do with that. So suppose my email address is like this, abcdefgh@gmail.com, right? This is my what? String, right? Or the email. So how do I get this info? Only this info. So how do I do that? I'll just write dot split. I'll write dot split on the basis of what? Space. No, space won't be used this time. This will be at symbol, right? At symbol. Okay. So when I do at, this is going to be split like this. In just imagine this as a binary tree or a tree. Okay. Or a beautiful diagram. Just imagine it like this. Okay. So maybe I can just draw it in the form of a diagram. So that's more clear. Suppose this is the thing, abcd@gmail.com. Okay. This is the what? This is nothing but the string here. Okay. But what if I do something like dot split on the basis of at? This is going to split something like this. It's going to split it like this. So ABCD part will come up here. Okay. ABCD part will come up here. Again, it's a string. It's not something like integer or something like that. At will be actually ignored because I'm splitting on basis of that. Then I'll be having gmail.com up here. So gmail.com. Okay. So again, if I want this one, this is being represented in the form of an array. I'll use the 0th index. Okay. Let's see if we can do something with this. So name is going to be what? Values dot split. Okay. Values dot split on the basis of what? At. Okay. On the basis of at. Yeah. I was struggling finding the at symbol. And then I'm going to take the first value itself. So if I just print name, and then I'll just have one space here so that it looks cool. Great. Let's see. So up here you can see Rahul, Arav, Ria. What if I have something, a name very small? Ri, right? I'll just save and then try to execute it again. You can see Rahul, Arav, Ri. What if I have something like Rahul Subramaniam? Okay, my bad if the spelling is wrong. So don't go harsh on me. So let's see. So you see Rahul Subramaniam. It should be Subramaniam. It's a bad spelling. So Arav and then Ri, right? So this is something known as string manipulation. Okay, you're sort of manipulating strings here. Okay, you're sort of manipulating strings here. Okay, and this is going to be important when you're doing what? Trees, graphs. Why am I saying this? Is you will be able to get that, right? Sometimes in graphs or trees, right? And sometimes in graphs or trees, what I'll do is just go up here. Okay, my bad. So sometimes in graphs or trees, what happens is generally on like 90% of the time, even 99% of the time, what values you will get is something like this. 99 trees, something like this. Or if I talk about a graph, right? It's something like this. 1, 2, 3, 4, something like this, right? Something like this graph will be there. Okay, something like this. But what if the graph has no numbers, right? What if the graph has something like this? in the input, node 1 is given, then node 2 is given, node 3 is given, then something like that. You have to convert this entire thing into something like this: 1, 2, 3, right? 1, 2, 3. And how do you do that? Again, you use dot split here. Dot split the space parameter, and then what will you take? Zeroth index part, or the first index part? You'll take the first index part, and then you can convert this node 1, node 2, node 3 sort of unwanted graph into a good numbered graph: 1, 2, 3. Okay, so why am I explaining this? All of these things, see, all learnings, right? All learnings, whether it be very small or big, is applicable everywhere. Okay, it's applicable everywhere. Some point of a time it is applicable. Okay, some point of a time it is applicable. So basically a good example of this is basically this thing, right? I'll just explain the hash map thing. It won't really take a lot of time. So basically, I believe so there was an interview which I was giving, and there was one concept called as, there was something called as the first interview which I gave on Python. The first interview which I gave on Python, right? I believe so the company was DXC or something like that, right? So the first interview which I gave on Python, I was able to answer maybe like 2 questions out of 10 questions asked, right? And at that point of a time, I was before the interview, I was feeling very confident. I know everything, right? I know everything. Before the interview, I was very confident. I knew everything, something like that, right? So the first Python 3 interview I gave, the Python interview I gave, he asked me, do you know Python? I said, yeah, I know Python. And then I was able to say only 10 out of 10 questions, or 2 out of 10 questions, or 2 or 3 out of 10 questions. And they're the basic questions. He asked me, what are the features of Python? What are the features of Python? I was not able to understand, right? But some of them, which I was not able to figure out, was PEP8. What is PEP8, right? And this is a very small thing. This is a very small thing. Like, okay, what am I drawing process? But this is a very small thing. You have to know. It's nothing but a Python enhancement proposal, right? PEP8 is a very small thing. What is monkey patching? What is monkey patching? What is monkey patching? What is monkey patching? I was not able to do this. Is again a very small thing, not a very big concept. Not a very big concept. What is pickling? What is pickling? What is unpickling? What is unpickling? Right? It's the same as the pickle which we eat for maybe like lunch or dinner. Pickle. So pickling, what is pickling? It's not really that, but the spelling I was trying to reference. So pickling, unpickling, what is that? What is object serialization? What is object serialization? Right? And these are very not big things, right? These are not big things. If you talk about list comprehension, right? If you talk about list comprehension, right? List comprehension, right? So this is going to be a little tougher. This is going to be a little tougher. I'm not saying big. List comprehension, an advanced one, right? Not a small, not a basic one. And an advanced list comprehension will be tougher than to understand what pickling and unpickling is, right? You will be able to understand this very easily. We will be able to understand what monkey patching is, what PEP8 is very easily. But what we do is we generally look up for the majorly asked concepts, right? But you have to be aware of the very small concepts as well, right? Very small concepts as well. There is something called as, which I have not yet covered. I'll be covering that. So there's something called as, what is difference between array and array list? What is the difference between array and array list? Right? There are some of these differences. How does the array size grows when we are adding any another element, right? Something like that. So these are very small things which also needs to be covered, and I'll be covering that. You don't need to worry about. So that's what I'm trying to say, that even if I talk about the strings, right? Strings. So you have to be aware of how to manipulate them. Manipulate them. Okay, you have to be aware about how to manipulate them. Okay, let's see. So now that we sort of know what the strings are, right? Let's talk a little about hash maps, right? Let's talk a little about hash maps. Let's see. So I'm going to write hash maps. Hash maps. And then maybe I can just have a dictionary here. So dict is going to be something like this, right? And dict, or maybe I can have something like hash map itself. And then I can have the roll number here, right? So roll number is 1001. What is the info here? The name is AB and the marks code is 45. Okay. And then I can have a roll number like 101, right? It's quite smaller than that. It's not an issue. Again, this is AV and the marks is 56. Again, I can have something like 1001 and then This is something like GH, name is GH, and marks code is 67, and another marks info is there 78. Okay, let's see. Let's see. I'm going to print hash map here. Okay, I'm going to print what? Hash map here. Hash map. Okay, I'm going to print hash map. I'll just save this. Let's see what it gives me. Let's see. Let's see. Let's see. So I'll just do this. I'll have whatever the thing is. Okay. So it's going to give me what? 1001 GH 6778 and then 101 AV 56. You will say, okay, no, you are wrong, right? Or maybe the computer is wrong, right? Because I've entered 3 key value pairs. This is the first one. This is the second one. This is the third one. But up here only 2 is there. Well, you might not have been, yet noticed. See, again, up there is this thing called, there might be some logical error. So basically, 1001, which is the key here, has been repeated up here, right? So which one will it take? The first one, it noticed that, okay, AB45 was there, but in the output is showing GH6778. Is it a coincidence? Let's see. What if I have something like for 101, right? So for 101, suppose I have something like ZZ, right? I have something like ZZ. Let's see. So what I'll do is maybe I can just execute this again. Again, I can see that ZZ is coming. No, that's not a coincidence. So it takes the last known value for the key. It's going to print the last known value for the key. Okay, this is how it works. Okay, so maybe I can just change this to 102, and this should be maybe like 103, right? So all of them are sort of different, right? So right now, if I just save them, if I just print it out, so up here you can see key 103, AB45 value, key 102, AB56 value, 1001. These are the values. 101 values only ZZ. Okay, I hope that makes sense. So again, you can get creative with hash map. Okay, you can get creative with hash map here. Okay, it's quite impressive to do that. Okay, so I believe so. If I'm not wrong, let me just try one thing. Print hash map dot get maybe like 104. Let me just check with that. Yep, definitely. Yeah. So what I'm trying to do here is, so that was printing hash map, right? That's not an issue. Okay. What I'm going to demonstrate here is, what if we want to add one value, right? Or one key value pair, right? If we want to add one key value pair, let me just open up the chat. Let's see if there is anything. Okay, today we have India-Pakistan match. Okay, great. Yeah, so we have a lot of things. So will you share any PPT? Hi bro, how are you? JavaScript number 1, understand. Okay, so are you saying that JavaScript is the number 1? Okay, I don't want to argue with that. Okay, JavaScript is the number 1. So do we get code file? Yeah, definitely we'll be getting the code file. I'll be uploading that. Okay, I'll be uploading that within 24 hours from now. Okay, so you can find it within 24 hours. So JavaScript number 1. I don't understand what you're trying to say, Jorev. So, okay, whatever the case may be. Yeah. So we want to add one key value pair. Okay, so how do I do that? I can just have something like hash map, right? Hash map. And then my key is going to be maybe like 34. Okay, 34 is my key. And then what will be my value? My value will be iNeuron. Okay, iNeuron. Okay, my bad. My spelling is wrong. I hope they don't sue me. So hash map 34 iNeuron. Okay. So this is what my key and value pair is. I want to add something like that. Again, I'm just going to print hash map. So my new hash map is what? I'll just have a hash map, right? And then maybe I can just try to execute this again. So you can see here, new hash map is this entire thing. Earlier, this hash map was there, but again, this has been added 34 iNeuron. Up here, 34 iNeuron is not there. Okay, let's see. What if I want to have the value for the key? Okay. What if I want to have the value for the key? What? 34, right? So the value for the key, maybe like 102, right? Maybe like 102. Okay. 102 is what? AV56. So AV56 will be given, right? So the value for the key 102 is hash map and then 102. Okay. It's as simple as that. As simple as that. Let's see. So up here, I'm going to execute. So you can see the value for the key 102 is AV56. Okay. Now imagine I write a value which is not there. Maybe like 95. 95 is not there. So hash map of 95, what is it going to say me? Let's see, 95. And then again, I'm going to try to execute. See, there's a key error. Up till then, new hash map is something like this, is completely fine. Up till here, new hash map is completely fine up till there, right? But where is the problem coming into the picture, right? Let's see. Okay, my bad. Yeah, great. So the value for the key 95 is hash map 95. Okay. So right now it's saying me key error 95, which means it's not there. So how do I avoid this error? So to avoid this error, the best way to do is hash map dot get 95. Okay. Dot get 95. If I just save this, and try to execute this again, sir, see what will you get? The value for the key 95 is none. It's not giving me error though. What if I have something like 34? It should give me iNeuron, right? Yeah, this will work fine. This will work fine because it's there. So there are two ways. See, the value for the key 34 is iNeuron. So there are two ways. The first one is what? The first one is hash map of 34, and the second one is hash map dot get 34. Which one is the better one? Which is the one is the better one, and the one which will avoid the error? This one, right? This is going to throw me an error if it's not there, right? And if it's there, it's definitely going to work fine, but this is not going to throw me an error in any case. Okay, so this is about it. Okay, now a little concept here and there about something like this thing. Okay, let me show you how to iterate over the hash map key and value pairs, right? How do you for loop through it? Okay, let's see how we can do that. So if I want to for loop through it, right? If I want to maybe like for loop through it, let's see what we can do. So suppose if I have an array, if I have an array ARR, okay? If I have an array ARR 10, 11, 12, and 13, what I can do is simply write for I in range. This is Python, right? Length is what? 4. So I in range 4. What I'll do is print ARR of I. And this is going to throw me what? 10, 11, 12, and 13. It's as simple as that. But what if I have a hash map? Hash map is something like this. 10 is having a value A. 12 is having a value B. 13 is having a value what? C. And this thing is itself, right? This thing. Now, can I use for I in range 4, for I in range 3 here? Because this is the first key and value pair, key and value pair, key and value pair. Can I use it like this? No, that's not the right approach for hash map, right? It's the right approach for what? Array, but not for hash map. So let's see what we can do. Up here, you can just simply write for what? Key in hash map. And then you can just simply do print hash map of key. Okay, this is one way. Other ways, for key comma value in hash map dot what? Items. And this is something which I expect you to not know from beforehand, because this is something which I also did not know, right? So hash map dot items, then you can just simply print what? Value, or you can just print key and value, something like that. Okay, so and get creative with that. This is also an approach. This is also an approach. Let's see if we can implement this up in the code itself. So what I'll do is for key in hash map. Okay, my bad, hash map. What I'll do is simply print. Maybe I can just print the key info as well, right? And this key is holding which value? It's holding this value. Okay, okay. It's not going to hold the value right like that. So it should be hash map of key, right? I hope that makes sense. So I'll just sort of save this, get rid of the entire mess, and then let's see. So up here again, see, it's completely working fine, right? So 103 is having this value. This is the key having this value. 1001 is having this value. And then 34 is having iNeuron. Okay. This is how it's going to work. Okay. This is how you sort of loop through that. Okay. Now here's the big deal. Here's the big deal. So what if, okay, what if you want to create your own hash map? You want to create your own hash map. A little algorithmic part comes into the picture. So if you have an array, ARR, okay, you have an array, numbers like this: 1, 1, 1, 2, 2, 2, 3, 3, 1, 1, 1. Oh, that's 31. I don't care about it. Then 3, 3. Okay. So if I want to create a hash map of this, and not really a hash map, but a frequency counter here, right? I want to create frequency hash map. I want to create what? Frequency hash map. How do I do that? I'll just loop in the array. So for element, or maybe like for number in array, I'll check that if number, right? I can just have a new hash map here. So hash map is empty. So by the way, this is how you declare an empty dictionary or a hash map in Python. So if number not in hash map, then hash map of number is going to be 1. Else what I'll do is hash map of number is already there. I'll just increase its counter by 1. Okay, and then I can just simply see what my hash map is. So I'll just print what? Hash map. Let's see. So right now I can see there are a bunch of ones. So that's 1, 2, 3 times 1, 4, 5, 6. So 1 is going to be 6 times, 2 is going to be 3 times, 3 is going to be 1, 2, 3, 4, 4 times, and 31 is going to be 1 time. Okay, let's see. So up here you can see 1 is going to be 6 times, 2 is going to be 3 times, 3 is going to be 4 times, 31 is only 1 time. So this is what I've created, frequency hash map. Now, what if I say that this entire thing can be done in one line? This entire thing can be done in one line. Well, you can do this with the help of something called counter. You don't need to know about this on a long-term basis, but if you are generally working with Python, you have to know about this. Okay, so counter. Okay, let's see what we can do. So you have to come sort of import this. So I can just use from collections, import counter, right? Counter with the C capital. And then up here, I can have something like C, which is my counter. I can simply write counter of what? Array. And then I can just simply print C. So C up here, you can see that instead of writing this big entire code, 1, 2, 3, 4, 5 or 6 lines of code, what I have done is simply written 2 lines of code, right? So there's a trade-off here, right? So I'll just save that, execute this, try to execute this. You can again see here that dictionary is throwing the values correctly, right? But up here I can see that this is also throwing me the correct values, right? 1 is 6 times, 3 is 4 times, 2 is 3 times, 31 is 1 times, right? But this is of type what? Dictionary or hash map sort of a thing, and this is a counter. Okay, that's what you have to care about. Okay, that's it. And I believe so this should wrap up for this session, right? Let me just quickly go through the chats if there is any doubts here and there. Okay, Athar, we already have a dictionary. Yeah, definitely. I was using dictionary the entire time, right? Also in an interview, you won't be allowed to do this, right? Until unless it's a Python-based core interview, you won't be allowed to import something like this, right? So you have to follow this approach itself to have a frequency hash map. Okay, that's it. We already have dictionary. Then what is the need of hash map? No, dictionary in Python, I'm implementing it. I'm implementing the same concept here, right? So basically, I'm using dictionary up here itself, right? Whatever this was. So this was hash map dictionary. This is a dictionary. If you want to see, right? If you want to see, what I can do is simply maybe like try to print. Yeah, definitely. Saurabh, yeah, you are true to some extent. So type hash map. If I just do something like this, maybe like try to execute this again. Up here, you can see class dictionary, class dict, right? That's what I'm trying to say. Okay. So I hope that makes sense. And I believe so that's it, right? I believe so that's it. Maybe I can share 1 or 2 things which is quite interesting. Okay, maybe I'll try to share that. Let's see what we can do. So we all are aware with what array is, right? We are all aware with what array is. Okay, great. Are you aware of this thing? Suppose array is there. I have something like 10, 11, 12, right? And again, I have 10. Okay, so this 10 is stored. So this is an object, right? 10 is an object, but this is stored in some memory, right? Some memory location, some location it is stored at. Okay, it's stored at some location. Okay, 11 is also stored at some location. 12 is also stored at some location. But is this 10 going to be stored at some location or the same one? But it's going to be located at the same one. How do I prove that? Well, that's something which you can do it something like this. So what you can do is simply create an array, right? Something like this. Maybe like 10, 11, 12, and 13. And then again, I can have a 10, right? Again, I can have a 10. Okay, great. Let's see. Print ID of, okay, my bad. So this should be print ID of ARR of what? 0. So this is going to be throwing me the address of 10, where it is stored. Let's see. So it's going to throw me this big address, right? 140229773236816. Okay. But what if I do an address of the last one, 10? It's going to be the same thing. Let's see. Just sort of remember what this is, right? So 140229773236816, right? If I check for the last one as well, I can see it's going to be the same, right? Let's see. Yeah, again, you can see it's the same thing. Let's see. I might be wrong here and there. Let's see. Yeah, it's the same thing, right? It's the same thing. So basically, if I get the address of this 10 and if I get this address of the 10, they are both the same. Okay, but 11, 12, and 13 are not the same, right? What if I do ID of ARR? Let's see. What if I do an ID of ARR? Let's see. So it's going to give me something like this. Okay, so this is something which I wanted to share. It's not something it's really mandatory to know. So I think this should be it for the session. I'll try to upload the files maybe like within 24 or 48 hours. And then tomorrow onwards, we are going to, maybe like not tomorrow, but the next community session, we are going to learn what? We are going to cover these things, okay? We are going to cover these things. As far as I remember, it's going to be linked list. It's going to be very important, min heap, very important. It's max heap, okay? On a general, it's a priority queue, right? Priority queue. And there are something like 2 or 3 more. Okay, this is something which you are going to be covering next Saturday, until and unless iNeuron declares any holiday. It might be some or the other reason for the holiday, right? So that's it, right? I hope the session was helpful for those who are watching, right? So basically, we can meet in the next session. Thank you. Okay, Attar, you can get the files, right? You want the files, right? Okay. Let me contact with the iNeuron team. If you want any updates, do look at the comments of this video. Okay, do look at the comments of the video. I hope you are getting me what I'm trying to say. So do look at the comments of the video. I'll try to get with the iNeuron team and upload it somewhere, and they will be sharing it with you. Okay, so you don't need to worry about it. So please do look at the comment or drop the same message, right? Drop the same message like, from where do we get the coding files? So iNeuron or I will be getting back to you. Okay, just drop the same query in the comment section. So I hope that would be it for the session. Let me wrap it up, and then we can meet in the next session with some valuable things, right? After linked list, min heap, max heap. In the next week, we are going to cover what? Next week, we are going to begin with what? Graphs, trees. Yeah. Don't call me sir, okay? So it's not like I'm a really aged person like that. So it's not like sir. So we are going to next week, we are going to cover graphs, trees, and then something like maybe other data structures, right? Other data structures. So these are the most important ones, which I feel like most people struggle at, right? We are also going to cover dynamic programming. Again, that's not something we have to worry about, right? Dynamic programming, again, I have to cover. See, if I cover maybe like 20 questions of dynamic programming, even you won't be able to do any question. Why am I saying this? You have to practice on your own. You have to practice a lot. If I say 20 questions to you, if I just explain 20 questions to you, you have to go back and practice 40 questions. You have to go back and practice 20 questions. Timing for next session. Okay. So timing for next session is going to be this. I'll just sort of write it like this: 6, 7. Next Saturday, right? So Saturday. Yeah. I think I should just wrap up the session. Thank you for tuning in.